Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. At this time, we are talking about CCP Data Engineer or Cloudera Certified Professional Data Engineer course curriculum. As part of this video, I will try to cover converting data from one file format to another. So for that, I am actually using the CloudX Lab. You can use Cloudera Quickstart VM also. Whatever you use, launch Hive. Make sure you already have a database. So in CloudX Lab, I have created a database training 8634 for me. For you, you should have your own database with your username, and make sure you switch to that database before running any commands, and hit enter, and you can see list of tables here. So these tables are created as part of the scoop command I have ran earlier. Okay, and there are tables such as departments, categories, customers, etc. So now they are asking to convert data from one file format to another. So there are multiple ways to do that. You can use Pig, you can use MapReduce, you can use Hive. In this case, I am using Hive. For that, we need to create a table first. So let's take an example of table called departments. So to get the structure of the table, you can say describe formatted departments and hit enter. Okay, and here you can see there are two columns, department ID and department name, and the table type is managed table, and this is the location in HDFS. And more importantly, you should look at these two: what is the input format and what is the output format. Input format is text input format, so the table is actually created as text file table. Okay, and output format is this one, which will be used to present the data when you run the queries. So now what they are saying is to insert this data into a different file format. So first we need to create a table with a different file format. So for that, first we need to understand the syntax of the create table command. So go to scroll down a little bit, and there is a official Hive documentation which you will have access to at the time of the certification. You can click on that, and then you can click on user and Hive SQL documentation. And here it gives all the documentation, so you can click on SQL language manual, and you can go to DDL statements here, and here you will see all the details related to DDL. So create database is the command to create the database, which we have used earlier. You can actually override the path by saying location. By default, it will go to the user warehouse. So when we actually created the database, what happened is, under warehouse directory, which is user Hive warehouse, there will be a directory by name training 8634 and extension .db. Hive warehouse. Yeah. So as the CloudX Lab is using Hortonworks as the distribution, the directory structures will little bit differ between Cloudera and this one. So to accurately identify the location of our databases, the default location of our databases in Hive in any environment is by running this command set hive.warehouse.dir and hit enter. I think it's set hive metastore warehouse dir. Yes. So this is the parameter which will control the location of the warehouse directory, hive metastore warehouse dir. So this is the command which you need to use. and this is the location where we have to check. So dfs-ls, dfs is an alternative for Hadoop, alias for Hadoop space fs to interact with HDFS in Hive context. So dfs-ls, apps Hive warehouse training star and hit enter. There are multiple directories here. Okay, there is only one directory with the training in it, but that directory have multiple files. That's why you will see multiple entries here. One common thing across all these 6 entries is this one, training8634.db. So when we actually create a database with create database command, there will be a directory with a .db extension, and that will be pointing to a database, and all the tables will again directories under the database itself. So after the import, it has created all 6 directories: categories, customers, departments, order items, orders, products, same as the table names from which the data is imported. Okay. So this create table will actually create database will actually create the database under warehouse directory by default, unless you specify location. If you specify location, it will use that location to create the directory for the database. Okay, and then we will quickly get into the create table command, which is the most important aspect of it, the current learning task. So this is the syntax. Create, you can use optional parameters such as temporary, external, then table, and there is a if not exists. So if the table does not exist, it will create, otherwise it will just gracefully come out of it without erroring out if you use if not exists. If you use it, if you don't use, then it will error out if you try to create the table with the same name, saying the table already exists. And then database name prefix, if you do not switch to the database, in this case we switch it to the database, so we don't need to use this prefix db.name. And then table name, and then you will give column names to create the table, and then there are other parameters as well. But for this task, where they are talking about convert data from one file format to another, the most important parameter which you need to look into is this one, file format. Okay, and the file format can be defined under here. So after create table command, after defining all the columns, row format is the command which will actually define the format of row, what is the field delimiter or column delimiter and row delimiter, and then stored as is the one which will actually define the file format. Okay, and here stored as file format clause, if you scroll down, all these are supported: sequence file, text file which is default, RC file, ORC, Parquet, Tableau, and also you can give any custom input format also. Okay, when you define custom input format, you have to provide Serde as well as input format and output format. If you use any of these supported formats, it will use the respective Serde input format and output format itself. You don't need to worry specifying those things. So in this case, the learning task is to convert data from one format to another. So first we have to create a table. So let me create a table, departments underscore avro. So I am trying to create a table, departments underscore avro, and for that I need to get the column names. Describe departments will give the column names in the table. Describe formatted departments will give the entire metadata of the table. So describe departments, there are 2 columns. So I will use create table departments underscore avro, department ID int, I am using the same column names, and department name string. And then if you want to if as part of the exam, if they ask you to specify the field delimiter, then you have to use row format fields, row format delimited fields terminated by. but that is not mandatory for most of the file formats. For text file format, if you want to change the delimiter, you have to use row format, delimited, fields terminated by. So changing the delimiters, you can specify that. I will cover later, but for now we will directly go into the stored as clause to specify other file formats. So the syntax looks like this. If you have to specify row format, you have to specify first row format, and then you can specify stored as row. That's it, and hit enter. Now the table is created. If you want to see the metadata of the table, describe formatted departments underscore avro, hit enter. You can see the column names here, then the location in HDFS. So this is the directory in HDFS pointing to this table. It's a managed table. If it is external table, it says external table. And then you can see, in this case, third input format and output format are different for this table compared to the earlier one. Here you can see different input formats and output formats, and here you can see different input and output formats. Okay, so now we want to transform data which is in text format with the delimiters that are specified here in departments table to avro format. For avro, you don't specify the delimiters, so you don't need to say row format, delimited, etc. So to actually load the data, you just have to say insert into table. What is the target table which into which we want to copy the data? Departments underscore avro, and the source of the table is select star from departments, and hit enter. And the data is copied. So again I am running describe formatted departments underscore avro to see what is there in that directory which is created for this table. So copy and then dfs -ls, paste here and hit enter. You can see it has created a file here, and the data is in avro format. Similarly, if you look at the original table from which the data is copied, you can see there are two files in it, and the data is readable. So you can actually say dfs -cat. So I am using the departments directory and trying to copy the data, read the data from files which starts with the part. So I have given pattern here and hit enter. We can see all the data in readable format. There is a null character delimited between delimiting the two fields, department ID and department name, but the content is text content. That's why we are seeing the data directly. If we do that on top of avro, there is no part in it, so you just have to say 00 star. So there is only one file and we are trying to read from that one file, and hit enter. You can see the data is in garbled format. Okay, so this is how the data is actually formatted by using the insert command. So here the idea is for you to understand the capability of insert command and the DDLs to define tables with a different format and use the insert command to transform the data from one format to another format. You can also change the delimiters. For example, the original data have delimiter null character. If you want to change the delimiter to something else and still store as text file, you can do that as well. So for that you just have to say create table departments piped department ID int department name string. There is a typo in the department ID name, but I will ignore, that's fine. Still I will go ahead and create the table. And now I want to change the delimiter. For that you can say row format delimited. Again, you can actually review the documentation for the syntax. Row format clause, you can scroll down for the row format clause here. You can terminate the fields, you can terminate the lines, you can also redefine null values. So you need to understand all these things to perform the task they ask in the exam. Okay, row format delimited. Fields, so here for fields, for row format delimited is mandatory. Row format delimited, fields terminated by whatever character we want. By the character I want to use to delimit is pipe. Okay, and then stored as text file, which is default. Even if I don't specify, it will be stored as text file only. I have to use terminated by, I missed the terminated by. So now I will fix the typo in the department ID name also, department ID column as well. So department name, row format, fields terminated by. Stored as text file. Now it is created without any issues. Describe formatted. So it will give the metadata of this. So this is the directory in which the table will be created. Copy this location, dfs-ls, paste it, and as of now there is nothing here. Now you can say insert into table. You can use any of the table, either departments or departments arrow. I am using departments arrow, and then select, sorry, the target is departments underscore piped. Source can be any table. So in this case I am using source as departments underscore arrow and hit enter. Again it will launch the MapReduce job in test context or MapReduce context depending upon the Hive execution engine, and it will load data into the new table. And now if you do cat departments underscore piped and hit enter, data will be in readable format, and you can see the fields are delimited by pipe. So using this insert command you can actually transform data from one format to another. Okay, first we have to create the table with the structure or format we want, and then we can run insert command, and that command will apply the necessary transformations to change the file format or to change the delimiters of the data. And finally, before closing this session, sometimes they might ask, not sometimes, in the exam they might ask the custom format also. So if they ask for the custom format, they will give a survey, and you have to add, sorry, they will give a jar file. You have to add that jar file, and you have to specify the custom format using input format and output format, and also you have to specify the survey. So the way you can actually specify the survey is like this. So stored as file format. So file format will be stored as input format class name, output format class name, and as part of the row format you can specify the survey with survey properties, etc. So it is a little bit complicated to remember this. Hence what you can do is, instead of remembering for custom formats, whatever tables you have, or you can create an empty table and then you can say show create table table name. So in this case let me give the arrow table departments underscore arrow, which is already created, and hit enter. So it will give the syntax of the create table command, which will actually specify how to give the survey at row format. So survey should be given here, and then input format have to be specified and output format should be specified. So instead of doing these things, we just say stored as Avro file, and it resolved this row format, input format and output format, because the Avro related jars are already integrated with Hive. If they give custom one, you have to add the jar file first, and you have to change the Faraday input format and output format by specifying this. But if they ask you to convert data into any of these formats such as sequence file, RC file, ORC, Parquet, Avro, or even text file, you can directly use as stored as the file format. Okay, so that's how you can actually change the file formats depending upon the task given to you. That being said, I hope you are enjoying the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about big data or Hadoop, please use my LinkedIn group called ITversity-Big Data. If you want to discuss further about certifications, please use my LinkedIn group called ITversity-Certifications. And if you are not subscribed to my channel yet, please do so. And also, if you live in countries such as US and UK, where fan funding is supported, you will see support this channel section here. You can click on that and contribute to whatever money you want to contribute, so that I can come up with more and more content like this over time. That being said, thank you, bye.